To check intersection without using the distance formula, which is helpful when you've got a shape that isn't a circle or doesn't have a uniform radius or diameter, you're going to need to do a little bit of checking of inequalities. So in this program, I've got just my lander object that has an x and y variable location. Drift is just a random horizontal movement, and speed is the vertical speed. So I give those all starting values. It's just a red circle, and then when it's moving, the fall is adding the speed on to the vertical location and drift on to the horizontal location, and there's just some key controlled movement. I also have a target, which is literally just a rectangle that is 40 pixels wide, 20 pixels high. This is important, rect mode center, so I'm doing the math from the center of that rectangle, and it's at the bottom of the screen. So what I'm doing here, again, like the class notes that I've already posted indicate, is I am checking to see if the x value of the lander object declared globally up here, the x is obviously local to the class. So if that x variable of the lander is greater than 30 minus the center of the rectangle, the x value of the rectangle minus 30, so 30 pixels to the left. So that includes, that's adding the half the width of that rectangle, so half of that width of the rectangle because of rect mode center. Adding to that the radius of the lander ellipse, so they're 30 pixels apart, so I know they'll still be intersecting if they are, the lander is 30 pixels to the left of the center of that rectangle. And then if it's less than the x location of the target plus 30, so again the sum of the half the width of that rectangle plus the radius of the ellipse, so the sum of that is 30, so I know they'll still be intersecting if the center, horizontal center of the rectangle and the center of the ellipse are 30 pixels apart, they'll still be intersecting. That's the edge of the places they could be intersecting. And because it's at the bottom of the screen, if the y value of the lander is greater than 20 minus the vertical center of the rectangle. So half the height of the rectangle is 10 because it's 20 pixels high, and the radius of the lander is still 20, or 10. So the sum of those two distances is 20. So I know when it's the center of the lander is 20 pixels above the center of the rectangle, it'll still be intersecting. And then it just changes both the vertical and horizontal speed to 0, so that it'll stop moving and gives you some feedback in this conditional statement. And this is all in draw. So, no, I've got to move it because it's drifting. So, great. So, I know that, again, horizontally, this distance right here from the center of the rectangle to its edge is 20. And then if this circle were over here, the maximum distance between the center, horizontal center of this rectangle and the center of this ellipse, horizontal center of the ellipse, is 30, by which they'd still be intersecting. Same on this side. So if the circle is greater than this center minus 30, so over here, or less than this center plus 30, so over here, then I know it's intersecting horizontally. And the same thing with vertically. This is 20 pixels high in all, so this distance from the vertical center to the top is 10. The distance between the circle and its edge is 10, so if I know if it is also 20 pixels above the center of this ellipse is 20 pixels above the center of this rectangle, the vertical center of this rectangle, then they're intersecting. And that will give us the positive feedback and, important, stop the circle from moving. I can modify this program to use an array. So if I'm going to make an array of little targets, I can say target spot equals new target, and let's make, 10 of them. I need to use my for loop in here. I equals 0, I is less than 10, I plus plus, and so spot I equals new target, oops, square brackets, not square brackets, parentheses for the constructor. Now I need to give, in order for them not all to be on top of each other, I'm just going to make the y random between 0 and, well, let's have it be, because it's 40 pixels wide, so between 20 and 480. Otherwise, nope, not the y value, Aaron. Oh my goodness gracious, that was that 480? Okay, the x value should be random between 20 and 480. This is 490. Otherwise, they'd all be on top of each other, so horizontally, they're going to be random. Now, I need to call this inside a for loop, otherwise, because right now, if I try this, there's no such thing as spot or spot x. There's only that entire array of objects, so it's the same thing for int I equals 0. I is less than when I make 10. I plus plus. And then make sure that's in a nested, close that bracket, so it's nested inside. And then everything where I see spot, I need to make it spot I. So spot I, so it's going to check every single one of those 10 spots 60 times a second to see if my ship is intersecting. So that should do it. I'm sure I've missed something. Yes, this also needs to be in that for loop, so I'm going to just cut it, put it right inside this for loop so as not to waste it. Make that an array 2. What did I do? Ooh. Oh, I see what I did. I changed. This was the lander. Oh my goodness gracious, I did this too quickly. So that was 250. This was what, like 10. Let's change these locations to random between 20 and 480. All right. Out of bounds, array exception 10. Oh, that's because I put 10 here. See, I should have prepped a little better for this one. There, so now if I go through that hole, they're not going to intersect. Got it. Oops, all right, I'm losing, but if I intersect with one of them, you win. Okay, so again, all of those, I can still use the same conditional statement. I just need to adjust because there's no single spot object anymore. There's only an array of them, spot 0, spot 1, spot 2, all the way up to spot 9. So I represent that with the I inside this for loop.